Perfect. Well, welcome everyone. We're really happy to have you join us for this webinar, the first one of our spring semester, in fact. And so before I jump into everything, I'd just like to give a broad overview of what this webinar is about and really the reasons that we're giving this particular webinar right now. So this one's meant to be really a first introduction or even maybe a second video you've seen on how to use JMP for your statistics courses. And so we really theme this for professors and students, but of course anyone who's getting started with JMP can get a lot out of this type of webinar. And so what I'm going to do today is talk a little bit about sort of JMP in general. If you've never even heard about JMP and are on the webinar, I want you to know really where JMP fits within the SAS family and how it relates to other statistical software. Then we're going to cover some JMP basics. We're going to talk about what I like to call the mind of JMP, really how JMP thinks about data and how we need to communicate with the software to really get it to do the things we want it to do. We'll talk about getting data into JMP, certainly something important if you want to analyze your own data. I'm going to talk about what I like to call the essential platforms in JMP, and I'll clarify what I mean by platforms a little bit later. But these are these big sections of the software that really will cover most analyses you would cover in a first or even a second course in statistics. Once we're done with that, I'm going to talk again about resources, but actually I like to start with the resources section right up front because there's a number of things I want to point out to you, especially if you're going to want to watch this webinar later or if you've never seen JMP and want to know how to get JMP. And so first I want to point you to really a great landing page, so the JMP academic homepage. That's at jmp.com/academic. And that's actually what I have pulled up on the right side here. So this is our academic landing page. And when you get here, there's a lot of things you can do. So if you want to know how to get JMP right away, you can click this link. I'll take you there in a second. If you're interested in learning JMP, you can click the Learn JMP link. It actually scrolls down the page. And these are some wonderful resources that Mia and I on the academic team put together for you. So we have getting started videos. We have a learning library, which contains guides and videos, really tutorials for performing specific tasks. I'll actually come back and show you those at the end. A case study library with real-world examples that you can use in your courses. Interactive learning tools. These are simulations that are actually built into the software, and I'll sort of point to these at the end as well. We also have a number of live webcasts. Of course, you're watching one now, so you know about these. Resources for AP Stats. We have books with JMP, and we have teaching materials if you're at a school that is actually licensing the software. You can get access to instructor course materials. And so certainly look at jmp.com/academic as a way to get started learning JMP after you've watched this video. Now, I said I would also talk about getting JMP, and actually I'll click on the Get JMP link because there are a number of different ways you can do this. Really, the premier way is a site license that gets every student at the university and every faculty access to the software. There's also individual licenses. So if you're not at a university that licenses the software, we have single user versions of the professional version of the software, academic versions that are perpetual, and even single user 6-month or 12-month licenses that students can get for their classes. So these are really affordable, $30 for 6 months or $50 for a year versions of the software. There's also a student edition of JMP, which is available for an entire campus for $500. And there's also institutional and staff licenses. And so we're always here to help you decide and to talk about any of these options. But know that JMP is very simple to get, easy to install, and very simple for students. Now, the other place I want to point you to is the JMP academic community. And the reason I want to mention this right now is just at jmp.com/jack. JMP Academic Community, and that'll pop you over to community.jmp.com, which is the main user community, but we've built a little subspace just for academics because we like to provide a number of special resources that we think are very useful for people teaching and learning JMP. And one reason I want to point you to this now, I certainly encourage you to look through all the resources here. We've really built a lot into this. But on the left-hand side, you'll see this collection of recent academic webinar recordings. And the reason I wanted to show you this is because this is where this recording will be after I finish it today. So I'm recording this locally, and I'll put a version up online. You can see the one from September is actually up there. And so I'll put the newest recording at the top. And so I encourage you, if you're looking today at this webinar, don't feel like you have to follow along with everything I do. Of course, I'm going to be showing you a lot. And if you want to revisit the material and try it again on your own, it's nice to have a recording. You can just pause and try it out on your own. So look for it there. So again, jmp.com/jack, and then click for the recent academic webinar recordings. All right, so with that prelude, let's actually get right into the software. In fact, I'm using JMP here the whole time. This is a little JMP journal, it's called, a way to organize output. And so what I like to do is start off with really a simple conversation about what JMP even is. You know, JMP is statistical software. You probably know that. But why is it a product of SAS, and why does it even really exist? And so JMP 1 actually started in 1989. So it's 26 years old now, and I'll give you a little screen image of that. There it is running on a Mac SE. And it started because one of the co-founders of SAS, John Saul, decided that he wanted statistical software that was intuitive and fast and powerful and would run on the desktop and use the mouse. Why can't we just use the mouse to click and drag and point and, design analyses? Why must we use command lines? And so he made JMP 1, and JMP actually stands for John's Macintosh Project. They didn't really have a name for it, so they just called it that. And so I'm going to pull up some examples while I keep talking, but JMP was originally designed to be this point-and-click interface to data. And what I mean by that is as I create analyses and output, the analysis really unfolds, and we're not stuck in an analysis. I can click things, I can interact, I can drag around my histograms here and see different memberships. These are actually species of flowers. And so Virginicas, we can see have the highest petal width. And so the idea is that analysis doesn't have to be limited to being simply a command line operation. Why not have an interface to data that allows you to drag things around and create visualizations really on the fly, and even layer those visuals or separate them out by different categories? Why does analysis have to be slow? And so that was the whole idea of JMP, to be beautiful, to be fast, to be easy, and to really allow individuals to work in flow. And so I know I'm doing a lot right here just to give you a sense of what this looks like. But the idea is that JMP is meant to facilitate good analysis of data, to make it quick and fast, and to encourage you to explore data. So I'm just pulling up a little map here of San Francisco crime, in fact. And so I did a bunch really quickly there, but the idea was just to show you that it's pretty easy, pretty fast, and very visual. And so what I want to do today is sort of step back and talk about how you can do these things in JMP and how you can get up to speed to really get the most out of your data and to analyze and to show students the power of statistics to make meaning from raw numbers. And so to do that, I'm going to pull up a very simple data set. These are sample data that I've built into the software. And I'll show you where to get to the sample data pretty soon. But sample data are nice because you can have all your students pull up the same data set in class, and they're typically built around a pretty simple structure. So this is a fairly simple sample data set of looking at restaurant tips for different tables at a restaurant. And so like most statistical software, it's built around a data set, and the data set has rows and columns. You'll notice that the first row doesn't contain the column names. There's actually a dedicated column header row. And so these are the column names. And really always in statistical software, at least ones that have structured data sets, the idea is that each column contains only a particular variable or a particular type of data. And so our bill amount column, of course, only contains data on bill amounts in dollars. And something like credit card column only contains whether somebody used a credit card or not. So again, like most statistical software, we have rows in the data set that represent the different observations. And something special about JMP you'll see is on the left-hand side, we actually have some extra sort of sections. This top section contains I'll show you later on are saved scripts. Scripts are things you can just run in a data set, and so you can actually create reproducible analyses, a nice feature of JMP. It also contains the file name and some other information, so references and information about them. The next section is our columns. Notice that these column names, and even when I click them, you'll see that they're selected in the data table itself. These just give you a list of the columns in your data table. And for a small data set like this, it doesn't really add too much power, but when you have very large data sets, it's very nice to have a scrollable list of your columns that allow you to select them or perform operations on them. You'll also note there's a little icon next to each of my columns. And I'll come back to this in a little bit. It's actually a very important thing in JMP. It's the modeling type of the data, which really breaks down to what type of data does this column contain. And these little blue triangles we call a continuous modeling type. And the red histogram here is a categorical or a nominal modeling type. And I'll come back to those names in just a second. But just so you see now, you can click on one of these to actually change the modeling type of a variable. And so if tip amounts really represented categories, not dollars, I could tell JMP that. JMP's going to make very good guesses about these modeling types, but this is always up to you. Now, something special about JMP that I'll come back to in sort of the mind of JMP section is that JMP pays attention to the type of data you have. Now, before we get there, let's continue looking at the data set overall. We have a rows section here, which is nice for us if we select rows. I'll select 5 of them. JMP even tells us we have 5 selected. If I were to exclude those rows, so remove them from an analysis, I can right-click. I can select hide and exclude. Notice JMP gives a little icon to these rows, and JMP even tells us there are 5 rows excluded and 5 rows hidden. Now, excluding and hiding are somewhat different. Excluding means removing from an analysis. Hiding means removing from a visual. Usually you do both, But you might imagine a time you want to exclude an outlier, but still show it on a scatter plot. So you don't want it entered into a calculation, but you still want to see it on the plot so you can circle it or show students that it's there. Let me go back. I'm going to right-click and remove these from hide and exclude. So now everything's back in the data table. Now, like most software, we have a menu item for analyze and graphing. Now, I'll talk about this in general. JMP organizes analyses in a very broad way, so into big domains of analysis. But the analyze menu is typically where you go for analyzing or producing statistical results, and the graph menu is typically where you go for performing graphical operations, getting a graph from your data. There's some other sort of menus that we can look at. So file has all our operations for getting data in and getting data out. The tables menu has operations for restructuring our data. And then we have our menu items for particular row operations and column operations. So things like hiding and excluding columns or hiding and excluding rows. All right, so that's the basic structure of the table. That's really how it looks and how JMP is organizing the observations. But the more interesting and I think more important part of this basic section is how JMP thinks about data. And I'm going to give you a simple little pithy statement I like to make about how JMP organizes its mind. And it's that JMP is organized or thinks about data in terms of the situation and not the particular statistic you want. And what I mean by this is that if you look at our Analyze menu, and especially if you're familiar with software like SPSS or Minitab, you're not going to see under the Analyze menu a t-test. In fact, you can dig through these menus as much as you want. You're not going to find a t-test under the Analyze menu. That's because JMP is organized around the situation. And so t-tests will occur actually in many different contexts. You can have a one sample t-test, and I'll sort of foreshadow that's going to be in the distribution platform. Or you can have a two sample t-test, and I'll foreshadow that's going to be in fit y by x. These platforms are really like big rooms. And within each room are analyses that are grouped together based on what they're aiming to do. And it's just like a room in your house, like the kitchen. There's a lot of tools in the kitchen that all sort of do the same thing or work for the same goal. And that whole room is different than maybe the living room, which has all sorts of other things. And so organizing the software around these big domains or big rooms means that when you enter into a particular room, all the tools that you need for that type of question are there. And so that's sort of a basic idea of what I mean by the situation and not the statistic. And so one thing I mentioned earlier is that JMP is going to pay attention when it's creating analyses to the modeling type of the data. That is what type of data each variable represents. And I mentioned that the red histogram is categorical data, nominal, meaning in name only. There's another modeling type, ordinal data, so ordered categories. And finally, quantitative data, which is really continuous measurements. Now, the reason that JMP organizes observations or wants to know what type of data each variable is because really the type of data you have circumscribes the set of analyses that are appropriate for those data. So, for instance, we know we can calculate a mean for numbers, but we would never try to calculate the mean for no's and yeses. And so JMP knows those operations or knows what's permissible, and so it's going to be very smart about what it gives us. And so let's actually take a look at these two ideas all at once. I'm going to go into a really important platform in JMP, the distribution platform. And when I launch this platform, JMP will ask us not what analysis we want to run. It just says what columns do we want to take with us into this room. And so I'm going to tell JMP I want to take the tip amount column. I can actually drag it over. And I want to take the credit card column. Here's another way to get it into the Y roll. I can click it here and click Y column. And there it goes. And so right now, we're just telling JMP what columns we want to take with us. When I click OK, JMP will produce the analysis result, the basic analyses for these two columns. Now, before I go any further, you may be, if you've never seen JMP, sort of put off by the fact that the histograms are vertical here. And this is something JMP does for conserving screen real estate. But before I go any further, I just want to show you everything in JMP is very customizable. So if you hate this view, and some people do, this topmost red triangle, and I'm going to come back and talk about red triangles quite a bit. They're menus in JMP. This topmost red triangle has an option called stack. And if you stack the distribution output, you'll get what might be a more familiar histogram, one that's on its side. And I'll just mention that everything in JMP is not only customizable, but can be set as a preference. And I like to do this at the very start. And if you go to JMP Preferences, for today, since I know most of you are probably used to histograms on their side, let's actually set it as a preference so you never see a vertical histogram. So if you go to your preferences and go to platforms, I'll go to distribution, and I'm going to tell Jump to always stack the output. And the reason I tell you to set it as a preference is these little outputs in Jump, when we create outputs from any platform, these are little interactive interfaces to data. And so what you want to do is really customize them to look and feel the way that you want to analyze data. So then the next time we produce an output, I'll actually do it for you again just so you see it really took. I'll go back to distribution. I'll take tip amount and credit card, click them into Y, click OK, and now I get the output the way I expect and the way I want. And so the great thing about Jump is it's very flexible and customizable to do exactly what we want. All right, so getting back to where we were, this distribution output is really just the first step along our journey with these two columns. Remember, we didn't select a t-test, even though maybe that's the direction we were going when we wanted to look at the tip amount column. What Jump did first is give us the basic output, and notice that it contextualized it on the basis of the type of data we had. That is, for the tip amount column, we got quantiles and summary statistics. For credit cards, we got a frequency table. Right? Jump knows that you're not going to produce quantiles and summary statistics for a column that's nominal. And so Jump already did something for us. It was already smart enough to say that these columns need different analyses for them. Now you'll notice I have another section, not just the modeling type, but the progressive interface. And this is a very special thing about Jump too. It's the way Jump was built from the start, to move forward or progress through an analysis. And so new options are always going to appear as you move through an analysis. And those red triangles, remember the one I clicked to stack the data, that's how you get additional options. So the red triangle up here, the one that was next to distribution, right? That red triangle at the very top applied to the whole platform. But notice there are red triangles next to each of our columns. So one for tip amount and one for credit card. And so if I click the tip amount red triangle, this will give me options that not only make sense for a continuous column, for a column of numbers, but also make sense given the context or the room I am in. Remember, I'm in the one sample room. I'm in the room that's all about the distribution of each variable one at a time. And so these options, these relate to not just the context, but also the room. And so we might want, for instance, a normal quantile plot if we wanted to assess the normality of a distribution, right? If I turn that on, it pops up in line. And this is, again, a very special thing about Jump. You're never going backwards. We don't go backwards to move forward. We can just move forward. And again, these are little interfaces to data. I can turn that on and off without ever leaving the platform. And remember, you could always set things as preferences. So if you're always turning on the normal quantile plot, you can have it as a preference so that it always appears when you open this room. So Jump can be customized to work exactly the way you work. Let's actually go forward though. So testing a mean may be something you would want to do if you were looking at the distribution of tip amount. And so let's actually see what happens here. I'm going to click test mean, and we're given sort of a panel where we have to specify the hypothesized mean, so under the null hypothesis. Let's imagine, historically we've always had tips that averaged exactly $4 because maybe we have historical data, and this is a particular week where we changed some things around in the restaurant. And so I'm just going to click OK, and notice that Jump produces that analysis and that test in line as well. So we get the hypothesized value, the degrees of freedom, the standard deviation, and we get our familiar t-statistics and our p-values. This is the two-tailed p-value, probability greater than the absolute value of t, and our one-tailed p-values. So Jump moves you forward through an analysis and gives you options that make sense. And Jump always likes to give you a graphic if it can, one that represents whatever the situation you're in is. This happens to be a representation of the sampling distribution of the mean under the null hypothesis that the mean is actually 4 in the population. And notice that our two-tailed p-value, this guy right here, well, that's just the shaded region of our sampling distribution, right? That's the proportion of time, if the null were true, that we would actually observe a sample mean difference as different or more different from the hypothesized mean than we actually got. Now, I'll mention something. When you're first learning Jump, I encourage you to click every red triangle you see. Remember, red triangles are little menus that give you more options that make sense in the context you're in. And so this red triangle, if we think about the context we're in, we are in a one sample platform, the distribution room. We just tested a mean for our continuous column. Well, what can we do now? Well, this is maybe where we want to look at a little animation about the p-value. So an interactive plot, if we want to actually look at, what would have happened to our p-value had we specified a different null hypothesis. Right? So these are great for teaching. We could even half our sample size. What would happen if we observed 60 people? Right? We can see the consequences of that for the sampling distribution of the mean. And you also have another little panel here for power animation. Great if you're teaching power and you want to show the consequences for alpha and beta errors, type 1 and type 2s. All right, so click every red triangle is my point here. See what JMP offers you when you produce analysis, because it's a great way to learn the software, but also a great way to learn new things. I often find new analyses just because JMP has offered them. All right, so that was all for a continuous column. Remember, at this very top section, we're in the distribution room, but looking at a numeric column. Notice that we have another red triangle for credit card, and we shouldn't expect to get the same options if we're working with categorical data. In fact, if I click this, you'll notice that we do get different options, right? Different things make sense given this context. We're still in a univariate or a one variable situation, but different operations are permissible on these categories. So for instance, a corresponding analysis to the t-test we just ran might be a one sample chi-square, a chi-square goodness of fit. And so that's right there under testing probabilities. And I'll just do this rather quickly. I'll put in half and a half. Let's assume under the null, we expected half of our individuals to be using credit cards and half not. There's some options here. We'll leave them at the default just to get the standard chi-square. And we get our output right there. And so notice that in the same platform, we're able to do very different things. But really, if we think back to the context we're in, these are the same types of operations. We're trying to test something about the distribution of these variables. It's just that the actual analysis that is relevant to testing a distribution differs because one variable is continuous and one variable is categorical. All right, so this is sort of all at once the idea of the situation, not the statistic. That JMP is paying attention to the modeling type of a variable, and it progresses you through an analysis. And this is true all over JMP, and we're going to see it today over and over, that as you produce analysis, you're going to get new options. And so always click those red triangles. And I'll make just one final point. This statistics index idea I have listed here. If you're just getting started with JMP and you're digging through menus looking for a particular analysis, it's very handy to know that you can actually jump right to one. So if you go to the Help menu and go to the Statistics Index, this is an option that you can use to really find out exactly where an analysis lives, or you can even launch it directly. And so if I were looking for a particular type of analysis, I'll just click and type something. A Mahalanobis distance. This is my favorite multivariate outlier detection. You can click Topic Help to know what it is, but if you click Launch, JMP will actually bring up the platform in which this analysis lives. I'll just put some columns in so it can produce it, and JMP will actually pre-populate the output with that measure. And so there it is, the Mahalanobis distance. And so remember, these things always live under red triangles, and so we're in a particular room in JMP, the multivariate room, and under the red triangle, well, under outliers is the Mahalanobis distance. And so the great thing about the statistics index is that it gives you a quick way to not only see if JMP does the analysis you're looking for, but where it is. So Topic Help will get you there as well. And so when you're first getting started, remember that the statistics index is there to help you out. The web help is also very good. If you search on the internet with just JMP and whatever analysis you want, you'll get right to our help files or even some of our videos. All right, so that's the basic mind of JMP. Again, the situation and not the statistic. And of course, when I mean the mind of JMP, this is sort of the collective influence of our developers and really John Saul and the way that they thought about analysis from the start. The fact that analysis should progress forward and that we should never have to tell JMP what type of analysis we're looking for if it can guess on the basis of the type of data we have. Right? We didn't have to tell JMP we needed a test of the mean, not a chi-square, because JMP knows you're of course testing the mean with a t-statistic, not a chi-square, if it's numeric data. All right, so one really important thing, I opened sample data to get to here, but how are you going to get your own data into JMP? Well, first let me show you about the sample data. The sample data in JMP is really easy to access. It's just under the Help menu, and you go right there to sample data. And if you're starting out with students in class, the sample data sets are really quite nice. They're usually quite clean. They usually have a little bit of context built around them. They're organized here by type of analysis they're good for. So if you're interested in showing, design of experiments, or let's say graph builder, here's a bunch of nice data sets that work very well for showing graphs. So you can just click on any of these, and this will pop up the data set just from the sample data directory. And you'll even notice that on the left-hand side, there are saved scripts. And so these are scripts you can run right away if you want to pull them up. So we can look at the famous Napoleon's March graphic here made in Graph Builder. And so the sample data are really nice if you're looking for just some basic data to get started. But you probably have your own data that you may want to work with, and certainly students will have their own data too. So let me first talk about importing data, and then I'll show you making a new data table. Both of these are very simple, and both of these work in just the way you would expect modern software to work. So importing data doesn't take anything special. Just go to File, go to Open. And JMP can open all sorts of different types of data. I'm going to go to the desktop. I'll just show you a couple here. Here's opening a text file. So this is big class. It's actually a sample data set, but saved as a text file. Now, this is one of the places where the Mac and the PC will differ a little bit. So on the Mac, you have an options section that I'll encourage you to open here. And the way I always recommend opening text files is using data, using preview. Now, on the PC, when you click the text file, your open button will have a little down arrow. And when you click on that, it actually prompts you to select which type of way you want to open it. And data using preview is really nice. And I'll show you why. When you open using preview, JMP brings the text import wizard up. And the text import wizard is great because it lets you specify the type of delimiters you have. You can be very flexible with this. If you're sampling from huge text files, you can even do subsetting or proportional sampling right here. And you can even work with specialized two-digit rules and changing things around as far as importing. And so for us, actually, JMP makes really good guesses about how our data set is set up. And so it recognizes that the file contains column names, actually on line 1. That's why they're bolded. And the data started on line 2. If I click Next, you'll notice that JMP even goes ahead and names those columns for us. And I can just click Import. And here we go. So that was from text. We imported directly into JMP. Now, I'll mention that when JMP imports data, it will make as best as possible a guess about the type of modeling types. So name, the student's name here, of course, is nominal. Those are just categories. If we look at age is listed here as continuous. It saw numbers. Sex is listed as categories, height and weight as numbers. Now, there are times when you actually want to override what JMP will have specified for the modeling type of a variable. And this is a good example of when. Sometimes we don't want to treat age as continuous. Maybe when we do an analysis, we're not interested in, let's say, a regression between age and height, but we want to do it as an ANOVA. And so note that you can just click on this little modeling type and change it to whatever modeling type you want. And so JMP will obey you even though it makes good guesses from the start. And so a lot of times people will treat age as ordinal. And so we can come back to that when we actually look at some bivariate analyses in a second. All right, so that was for opening a text file. Let's try it with an Excel file. I'll just go to File, Open again, go back to my desktop, and you'll see I have big class here. If you click on Options, you have, again, different methods of opening. You can open all the sheets directly, select individual sheets, or use what really is my favorite, the Excel wizard. And so when you launch this, the Excel wizard, much like the text import wizard, gives you controls for where the data are in your data set. And this is very important because, like many of you, my Excel files have lots of rows even before the data starts. I have, titles and other stuff in there. And so instead of having to clean up the Excel file before you import, you can actually just control where the data are for JMP here. And if I click Import, notice that JMP brings it right in. It looks just the same way as it did with text. So really quite easy to get data in. All right, so that's bringing data in. You can bring in from many different types of data, including SPSS, R, MATLAB, Minitab. So JMP is really very easy to get data in. JMP also lets you do opens from the internet. So if you have data sitting in an HTML table on a website, let's say you're on a Wikipedia page and you want to bring in the table, you can just point JMP to that URL, and JMP will actually scrape and parse the HTML tables and bring it right into JMP. So a really nice, handy feature, especially when you're pulling off the internet. But sometimes you're making a new data table and entering in data from scratch. And so that, again, like any modern software, is just File, New. You have a lot of different things you can make, scripts, journals, applications. We're just going to do a new data table. And so the new data table starts off really with one column with no name. If you double click that column, you actually get to the column properties, something I haven't shown you yet. Here you can name the column, you can define the type of data it is, the modeling type of the data, all sorts of things, including formatting. You can initialize the data, and columns themselves can take on lots of properties, which is really outside the scope of today, but our other webinars will talk a lot about column properties. And so here you can give the column a name if you like. If you want to make new columns, there's lots of ways to do that. The columns menu lets you make new columns one at a time, add multiple columns all at once, or you can even just double click in a blank section. That'll add a new column. You'll notice that we don't have any rows here. Since JMP is a structured data set, rows don't exist until there are data there. And so when I type in any of the columns, I'll put a 1 in column 1. Notice now we have one row. if I were to add a value in column 3 down here, notice that JMP is not going to just treat these all as empty, or sorry, as just blank. It actually knows they're empty. Since this is a structured table, if you entered in the 12th row for column 3, JMP thinks you missed those observations for the first 11 rows. And so adding rows is very simple, but do be aware that as a structured table, you only want to add as much data as you actually have. Unlike Excel, where you have parts of data in different sections of a table, JMP really wants your data to be all contiguous. And so entering data is quite simple. Simply just enter it in. Deleting and modifying columns is just as simple as you would expect. You can delete columns by dragging, right-clicking, and just delete. Like most things in JMP, you can right-click. And so if you're looking for an option, certainly try right-clicking or looking for a red triangle. Those are the two big ways to get to any kind of operation. All right. So now that we've talked about some real basic things and seen sort of how JMP thinks about data, I want to take you through a tour of what are the essential platforms. And of course, we're not going to be able to dive too deeply into all of these, but certainly for a first or second course, I want you to see where you would produce all the analyses that you would need for those courses. And so let's return to distribution for just a second, just so I can talk a little bit more about some of the special features and usefulnesses of JMP for distribution. And so we've already talked about some of these. Let me produce some new output. I'll go back to Analyze, Distribution. And what I'm going to do is take a couple more columns this time. We'll take 4 of them. Click them into Y and click OK. Now, one thing I always like about JMP is when you're first getting a new data set, certainly the best way to get to know the data, to know what observations you have and really what you're even looking at, is looking at histograms. And this is one reason why when I first started using JMP 10 years ago, it was really impressive to me that I hadn't thought of this before. I was an SPSS user and I used Excel a lot. Many of you may have tried to make histograms in Excel and fought with it there. But histograms are a great way to get a sense of the data. And one thing I love about JMP, and I showed it very quickly at the start, is that these histograms are interactive. And so, for instance, if I drag a box around these points that are marked as outliers, so it's using a Tukey criterion, so 1.5 times the interquartile range plus the third quartile gives us the outer fence. And points that are beyond the outer fence are just far from the median. And so I can select those here. And notice what happened. In every other plot, JMP selected those outliers, or quote-unquote outliers. And so not only do I get a sense in a univariate way of each of these variables, but I also get a sense of observations across distributions. And you'll notice something else. I'm going to move this plot down, or move it to the side, I guess. Notice that the observations I selected here, they're selected in the table as well. Now, what's powerful about this is, let's say I'm actually doing analyses for research, and I have as my standard for outlier detection, this Tukey procedure. I can right-click and actually exclude these right here. That is, I don't need to go digging for what observations those were, the ones that were outlying. They're selected in my table because JMP globally selects. I like to call it the ubiquitous selection of points. Now, this is cool from a research standpoint. Of course, it makes it very easy for me to hide and exclude points. But I think it also makes very manifest the somewhat abstract relationship between rows in a table and points on a histogram. Like if I collect or select these lower tables, the ones that had low bills, well, there they are in the table. There's no question about where they are in the histogram. It knows where they are. And so this is true all across JMP. When you select points or select observations anywhere, they'll be globally selected, no matter what platform you're in. I mean, I can go into a 3D scatter plot here, and I'm still going to have those observations selected. There they are at the lower side. And so what's beautiful about JMP and this global selection is you get a way to touch your data that's profoundly useful pedagogically. As students actually touch these observations, they see the relation between where they are in every observation or every output they have. And so I think that's a special sort of feature of JMP that's not worth overlooking. Now, another useful thing about the distribution platform, again, as I select observations and I work through them, I can make subsets, I can apply labels. One of my favorite things, and I talk about this in more advanced webinars, especially for research, is if you drag a selection around observations, right-click, you can actually name that selection in a brand new column. And I point this out because it's so useful. We can actually just name the selection. I'll say these are our high bill amounts. And the selected ones can be given a 1 and the unselected a 0. And look what this does is I have a new column in my data set where those observations that were high or low bills are now categorically different, 1s and 0s. And so you can make these subsets or make these cut points very easy. And so again, that's just a nice thing in distribution. Drag a box or just select points anywhere. right-click, and name selection and column. In fact, that's true anywhere in JMP that you can select a point or select an observation. And so remember, you can always operate on things just by clicking and dragging around them. Now, of course, distribution gives you a lot of options. Those red triangles are worth looking through. In a first or second course, you're certainly going to be testing the mean. You can do this as a Z or a t-test if you happen to know the population standard deviation or variance. You can actually provide it to JMP here. That's fairly atypical in real-life circumstances. And you can also produce the Wilcoxon signed rank, so if you're doing non-parametric versions. I showed before that for categorical columns, you can, of course, test the proportions or probabilities. So that's that chi-square goodness of fit. And you can also get confidence intervals here. So if you want your confidence intervals about the frequencies or proportions, you can get the score confidence intervals there. Similarly, for our tip amount, you'll see we already have the upper and lower 95% confidence interval there. But there's plenty of other options here that you may be interested in getting. So especially for a first course, you may actually want to produce that stem and leaf plot. And this is, again, interactive. If you notice, I can select the individuals in the stem and leaf. And so if you want to make that connection for students, this is a nice way of showing the individual observations. I think it's really nice pedagogically. So the distribution platform is very flexible, not just for first getting to know your data, but also for producing all those univariate analyses. But that's only going to start us off in a course. And so the next place to go, and I'm actually going to skip over Graph Builder and we're going to come back to it, really the next step up in complexity is going to be when you start talking about bivariate relationships. And bivariate relationships really come in one of four flavors, and I'll show you where this plot is in just a second. But before we get there, think of this as a little two-way table. And the x-axis here in the x section is what type of modeling type your x variable is. So is it numeric or continuous, or is it categorical, nominal, or ordinal? And what the y variable is. So is it continuous, or is it categorical? And the intersection of these two is really the type of analysis you're talking about if you're talking about a bivariate or two-variable analysis, right? If your x variable is categories, let's say tip amount, and your y variable is numeric, let's say number of guests, right? Then that's really the domain of ANOVA or t-tests. If you have two continuous variables, let's say you're talking about number of guests on the x and on the y bill amount, well, that's really the domain of regression. We call that bivariate. And so this little table is really all the four types of analyses you can get based on the type of data for each your x and your y. And if I go to fit y by x, you'll notice that that's actually, I just stole it from there. It's just the actual legend showing us the type of analysis this room will produce. And so fit y by x is kind of special. We call it a contextual platform. Really everything in JMP is contextual. But we're about to enter the fit y by x room, but this room has four sides to it, or four corners. In one corner of the room, we're doing regression. In another corner, we're doing ANOVA type analyses. In another corner, we're going to do logistic. And in yet another corner, we're doing contingency. So things like chi-square test of independence. And the beautiful thing about this, and this is true again all over JMP, is JMP knows which side of the room we're going to because we've already told it what type of variables we have. So let me give you a sense of this. So let's say we're using credit cards as our x variable. And this is going to be really us teaching two-sample t-tests, so t-tests for independent samples. So we have credit card on the x-axis, and let's say we're looking at how people who do and do not use credit cards maybe tip differently, so tip amounts. Maybe we have a hypothesis that if people use a credit card, intrinsically their money is less real to them, so they feel more willing to tip. And so maybe that's a hypothesis we want to test. Notice that JMP, and you may not have seen it happen in real time, but it did. JMP tells us, based on the type of data we just put in there, this is going to be a one-way. We're taking you to this corner of the room, the one-way corner. And let me click OK. Now, before I do anything else, and I'm just going to leave that there, I'm going to go back to fit y by x, and I want to do something. I'm going to hit recall, just so you think I'm not cheating. I'm going to take out credit card, and I'm going to put in a different variable for the x, number of guests. And before I click it in, I want you to focus your attention right over here, because what's going to pop up when I click this in is bivariate. So JMP knows it's a different corner of the room, and it only differed because I changed the x-axis. So the same y response, but a different x variable. And so when I click OK, I'm going to get that output. Now, before I go any further, you may have the thought that I did when I first started using JMP about a decade ago. I said, where are my analyses? Right? I thought I was going to go into a room with linear regression, and on the left-hand side, I thought I was going to get a t-test. Now, JMP starts off with a graphic. JMP is graphics forward, but it doesn't force you into a type of analysis. Remember, these are big rooms or sides of a room, and there's lots of different analyses that make sense when we have a nominal x and a continuous y. A t-test isn't the only one. Maybe you were actually interested in whether the variances of these two groups differed, right? Or maybe you wanted to do a non-parametric version of a test. Specifying a t-test at the start or forcing you into that would actually be wrong. JMP wants to give you all the options. Similarly, on the right-hand side, maybe you wanted to fit a line, but I don't know, maybe you wanted to fit a polynomial. There are lots of analyses that are applicable given the context here. Remember, JMP is context sensitive. And remember how to get to those options? Remember what I said? Click every red triangle. So on the left-hand side, here's the red triangle there. Remember, those are context-dependent options. So there's the one I thought I was going to get, my either a means, ANOVA, and pooled t, or a t-test not assuming equal variances. Maybe I just want to know the means and standard deviations for those two groups. Or maybe I want to compare them in a non-parametric way. Or, hey, there's the unequal variances option, so I can do tests to see if the variances in these two groups are different. Our hypotheses don't always have to be about the means. So all these options make sense given the context, which is why JMP is offering them to us. So let me just produce I'll produce just the t-test here. This is the t-test not assuming equal variances. And we produce a familiar t-test output. So we get the t ratio, we get our p-values. I'm going to turn on something else that I like to turn on. I'm just going to turn on means and standard deviation. And so we'll get a little mean box there. I could actually turn off the points if you want to see it a little better. I'll go to display options and let me turn off the points. And there we go. We have the means and standard errors, and so the standard deviation markers as well. And so we have a lot of options there, and I'll turn the points back on just so it looks similar to the right-hand side. But notice that the graphics really start us off to let us see the data or to see what we have. Now, the left-hand side, again, these are all the options that relate to the tests of means or comparisons among means, because that's the context we're in. On the right-hand side, we're really talking about analyses that relate to the conditional mean of y based on x, and what that conditionality is, whether it's linear or based on a polynomial. Those are all choices we get to make. And so under that red triangle, we can do lots of things. Perhaps the most obvious and the reason most people would be doing this in a stats class might be because you want to do linear regression. And so if we do this, we'll regress y onto x. And if we scroll down, we get a lot of output, but very familiar output if you've done regression before. So summary of fit table, which I can minimize here just as we go along. An overall ANOVA table, probably the thing you most want are your parameter estimates. And so the intercept of this line and the number of guessed slope, right? And our familiar t ratio and p-values. And so notice that JMP gave you these options after you entered the room. And so this is something to remember about JMP. You enter the room first based on the context of your data, and then JMP will give you plenty of options. And the nice thing is, if we really wanted to compare, let's say this to not that we would want to do it, a quadratic fit, we can do the polynomial right there in the same room, and JMP will produce these inline. Now, remember, I said always click every red triangle as you're producing analyses. And notice there's a new red triangle here for linear fit and one for polynomial. I'll go to the polynomial first so I can remove it. So let's just focus our attention on the linear. And I want you to see that there's plenty of options even after you fit the line. So one thing that I think is fairly useful is turning on the confidence bands for the shaded fit or shaded confidence bands. I think these are nice, the working hoteling confidence strip. And so this gives us a little sense of the uncertainty of that line. And there's plenty of other things that you might do, especially in a stats class. Maybe a second quarter stats class, you might talk about residuals. And so you can plot the residuals directly here. Very good thing for students, especially once you're really preparing them to work with real data, because they should really be diagnosing the sort of correctness of this model for the data. And so you get what we call the residual bundle, so by predicteds and some other things. And so certainly click every red triangle. And under here, there's plenty of options, and as we move forward in the software, you'll see there are different ways of doing linear regression where we can even get more options than this. But notice that the fit y by x room, the point here is that it adapts to the situation we're in. And so let's try a slightly different context. I can close both of these out. And let me do just one different context here, and then I want to show you tabulate, fit model, and multivariate. Another context might be if we're trying to produce an analysis looking at two categorical variables. We want to know perhaps there's some relationship between credit card use and the type of server we have. And so we have 3 servers in this data set, A, B, and C. Maybe one server or another server tends to encourage people to use credit cards or not, and we want to assess that. And notice that jump again specified this as contingency. It knows that with two categorical variables, we're producing that particular type of analysis. Let me click OK. We're going to get a number of things right away. With contingency analyses, JMP will pre-produce at the very bottom here your familiar Pearson chi-square and likelihood ratio chi-square. So that test gets popped out originally. Our contingency table shows us a number of things. It took me a little time to figure out what I was doing here. So these 4 rows within each cell are these 4 things: the count, the total, the column percent, and the row percent. Now you can always right-click and turn on or off different things. You can get each cell's chi-square. This is great when you're teaching chi-square first and you actually want them to calculate this. You can get the expected values under the null for each of the chi-squares. These are nice, again, when you're teaching. But when you're actually analyzing, most of the time we're looking at either the column or the row percent to think about how things differ. But my favorite thing about this platform is this output. So if you've never seen JMP before, you may never have seen a mosaic plot before. But the mosaic plot is kind of magical. It's doing 3 things at once for us. It's showing us the marginal distribution of credit card use. And by that, I mean how many people in this data set did or did not use a credit card. It's also showing us the marginal distribution of server. So how many observations were from server A, B, and C. And it's showing us the contingent distributions of server based on credit card use or credit card use based on server, depending on how you want to look at it. Let me show you where those things are in here. So actually, I'm going to drag this out a little bit, the Y's and the S's. So here is the marginal distribution. If you just look at this section here, notice that the no's overtake the S's. Well, there's more no's in the data set than yeses. I'm actually going to right-click, go to cell labeling, and I'm going to show the percents just so you can see them. So 67.5 or 67.5% of the data set was no's and 32.5 yeses. So that's the marginal distribution of yeses and no's. The marginal distribution of server is perhaps a little bit less hard to see, or a little less easy to see, but once you notice it, it's pretty easy. The C group here, notice the width of this bar right here. Well, that's less than the B width, which is all less than the A width, or maybe A's and B's are about the same. So the spacing in the x-axis is actually the marginal distribution of server. We have the fewest observation from C, and then B and A are pretty similar. I can again go to cell labeling, show percents, and we can look at the internals. So I actually sort of jumped ahead of myself here. So the magic of the contingency plot is the internal parts here. So within the A group, we have a proportionality of credit card use that is slightly different than the proportionality within the B, which is again different from the proportionality of the C. And so really the point of the chi-square test of independence is, do we think that the heterogeneity in the internal proportionality, the contingent proportions, is different than the average because of something real in the population being these servers over an infinite number of tables, I guess, or do we think that's just noise, right? Is this distributional difference within each server for credit card use really just noise? And that's what our chi-square test of independence is helping us see. And so this plot is great because as you have more and more deviations from what is expected under the null, it becomes more and more obvious. And so I'll just do one in this data set that's pretty obvious. And so if we do, I think we do day of week and server, it should be pretty obvious that they differ. So again, looking at this, the A, B, and C people now are the different bar colors. Notice that on Monday, only the B server was working. On Tuesday, it was A and C. Wednesday, these are all kind of similar proportions. But obviously, maybe Monday, C and A just had the day off. So it's obviously different. And so when you have the mosaic plots, it's almost like a pop-out effect. You can tell when the contingent distributions are very different across the x-axis. So I certainly like fit y by x for that. And so mosaic plots are a very nice thing to show. All right, so let's actually, before we go on and fit y by x, I want to show you a couple really essential platforms in JMP. And I'm going to do these a little bit more quickly. And so I'll go back to Graph Builder, because Graph Builder, even though it's sort of something we're hitting at the end, is something that I often like to start students with. And so Graph Builder is actually under the Graph menu. And this is the basic place to go for graphing in JMP. And I think it's just incredible. It's drag and drop graphing. And what's really amazing about it is you get to profile different graphics as you're building the graph itself. And the way it works is around drop zones. And you'll see I have a Y drop zone, an X drop zone, group X, wrap, group Y, and some other stuff over here we're all going to get to. But let's just start off with a basic visual. So I was looking in fit y by x at credit cards. I'm going to drag that down to X. It starts off with just a point cloud which may seem kind of useless, but it's actually kind of neat. You can see there's already more people in no than yes, so the points are jittered and spaced there, so we can see that. But let's look at tip amount. Right, that was something I was doing before. We again get our point clouds. That's actually how fit y by x started for us, remember? And then we can do a number of things. If you look at the ribbon at the top, these are all different visuals that are making sense. Notice that it wouldn't make sense to fit a line between these. There's no way we can fit a line between no's and yeses in a linear regression sense. We can draw a line between them. I can click that, and that's one way of representing. It's not very good data practice, right? These are categorical, so the midpoint here makes no sense. So maybe we would want a bar. JMP's not going to enforce you to use bars, but you can certainly get a more sensible graphic that way. Or maybe we want a box plot. I actually like box plots a lot. We get a sense of the variability of the data, not just the mean of the data. But let me go back to bars, because you'll notice that sometimes we want bars with error bars or other characteristics. Those are all controllable in the little control panel on the left. So let me click on some error bars here. And as we're building this graphic, we may get another idea in our head. Maybe the difference between credit cards, no's and yeses, for tip amounts, maybe that's not the same for our different servers. And so let's actually invoke another variable in this data set. And this is where we can use some of the other drop zones in the data. And so if I drag server, now I'm not going to drop it. I'm just going to drag it to some different places so you see what happens. If I drag it to the top, notice that this group for x means literally group the x-axis on the basis of the levels of that variable. And so we can actually look across to see, whether the credit card no yes difference is the same for the servers. Wrapping, the section on the corner here, that goes left to right. Group for y, does it top to bottom. Now, this is actually a great time when I talk to students really about good practices in visualization. Now, you always want your graphic to tell the story of whatever you're trying to explain. And so this is a great example of a graph that, although technically correct, doesn't really tell any story at all. I find it very difficult to see whether the servers differ in terms of their difference in credit card use. And so this might actually be a place where you can drag around to different sections, see which one tells the story the best. Hey, overlay seems to do it pretty well. Overlay puts them all next to each other, so the no's and the yeses. And so notice that just by having the flexibility to move variables around, we can actually try out a number of different graphics. I often get the question, what's the right graphic for these data? But it's really, what's the right graphic to show the story you want to tell? All right, so let me click Start Over. And I want you to see that JMP will give us different options when we put in different variables. Another thing we looked at was, I believe we did number of guests, and we looked at tip amount. Let's try that. And notice that JMP starts off with kind of this flexible moving line, something we can change here, the smoother. But this is a situation where we really could turn on the linear regression. And we can click it on there. Now we get some options. We can turn on the equation for the line, or maybe we want to show the prediction band as well. So this isn't really an analysis platform, but certainly is a platform that lets us explore data. Again, we can invoke other columns. So maybe we want to group this by credit cards, yeses and nos. Right, so we can drag these in. So Graph Builder really is a nice way to profile and explore different visuals, and certainly look at some of our other webinars when we take a deeper dive into all the flexibility of Graph Builder. But just so you can see, when you're done with it, just click Done, and now you have a graphic that you can use. I didn't mention it before, but getting graphics out of JMP is as simply as going to File, Export if you're on the Mac, or File, Save As if you're on the PC. And one other way to get them out, and this is kind of important, under the Tools menu, there's this Selection tool. And the Selection tool is great. When you turn this on, you can select any object you want in JMP. And so if I select, let's say, the whole Graph Builder section, I can now just go and copy this. And if I copy it and take it over to another program, I have Preview on my Mac, so I'm going to go over there and just make a new from clipboard. Now I can actually take this and save it out as a PDF. And so you can paste this into really anything you want, or just, if you're on a Mac, just take it over to Preview. And so again, that Selection tool under the Tools menu is a handy way of grabbing any kind of output you want in JMP. And we think it's really great to, especially when you're producing publication graphics, make sure you copy it out and you can save it as a really high resolution graphic. All right, so that's graphing in JMP very simply. What about the equivalent if we wanted to make tables? Well, that's a different room in JMP. It's called Tabulate. And again, I could show this fairly quickly under the Analyze menu. I'll go to Tabulate. And notice that Tabulate, again, is built around the idea of drop zones. Here, it's about drop zones for making tables. And so just like for Graph Builder, I always like to start off with the idea of what are you trying to show, or imagine the kind of table you would like to make. And so let's imagine we're making a table. We just want to know what the total amount of tips it is for each of our servers. That's all we want to calculate. And so we can start with a number of different ways here. I always like to start with the variables that define the groups. So I'm going to grab server, and I'm going to drag it over to the drop zone for rows. And notice when I hover over a drop zone, it highlights. So if I drop it there, it starts off by telling us A, B, and C with a very simple summary statistic, the number of observations in each of those cells. And so now we want to add in another variable, tip amount. So let me drag this over, and the place to drop it when you want it to calculate on this variable is right here on top of those numbers. Notice that highlights. Now, the default summary statistic turns out to be the sum, and that's actually what we were looking for in general. So we wanted the total amount for each of these different servers. Let's imagine instead of the total, you actually wanted to know the average amount. Well, there's a couple things we can do. Notice there's a whole list of summary statistics here. I can click and drag one on top of sum, and sort of in JMP's mind, whenever you drop on top of another variable, it thinks that means you want to replace that variable. So when I drop it here, there it goes, and it replaces it to be the mean. I'm going to click undo because I want you to see another thing you can do. I'm going to click and drag, but not drop on top of sum, but watch the box. There's actually, if I go to the right-hand side, a little drop zone there, and a little drop zone here to the left. Those are the prepending and appending drop zones. So if I drop the little box on the right, it'll add that summary statistic. And what's cool about this is you can actually grab a bunch of these and drag them into the little drop zone to the right, and now we can build a table with all sorts of statistics. Now, in addition to this, the little drop zones to the right and left are going to work for categorical separators. So we had server here. What if we wanted to break this into day of week as well? Well, let's drag day of week. I'm going to drag it to the left of server. Notice there's a little box there. And notice now we build a table that has it broken up by day of week and server. Notice that we've found this before. On Monday, there was only one of the servers, so we don't have blanks there for the others. We could do something different. If I want a day of week on the other side of server, I can just click and drag it across, and now I built it that way. And so Tabulate is really flexible. It's a great way to build these tables of whatever summary statistics you want, and it's also good sometimes when you're restructuring data. Just like in Graph Builder, you can click Done when you're done. And this is very important when you're working with tables. Sometimes you want this tabulation to actually be a proper JMP data set. And so the red triangle, remember, click every red triangle when you're first learning JMP. You can select Make into Data Table, which will actually let you create it into a proper JMP data set. And so Tabulate's a really, really great platform, especially when you're building basic tables at the start of a class. Now, I won't have time to talk about them. That's why they're separated here. In our more advanced webinars, we'll talk about Fit Model. Fit Model is, certainly for a second course in stats, multi-factor analysis of variance or multiple regression. So Fit Model is under the Analyze menu, and just like Fit Y by X or distribution, it will be, in a sense, context dependent, but we develop model effects now because we'll have multiple effects within any given model. And so Fit Model is a very powerful modeling platform that covers everything from simple analyses all the way up to generalized regression and mixed models. And finally, multivariate is I showed it a little bit when I was talking about actually the statistics index. So under multivariate methods, multivariate, this is sort of the multivariate extension of distribution. So you can give it a number of numeric columns, and it's all about correlations and relationships among these variables. So you get your scatter plot matrix, and you might remember from the very start, this is where I showed outlier analysis. So Mahalanobis distance being a great way to look for multivariate outliers. But again, this is the idea of getting a good picture of the interrelationships of all your variables. And so just to remind you, under resources, come check out the recording of this webinar. It's going to be in the academic community, and certainly look at the academic homepage. We have a wealth of resources there for you to check out. And so I think I have 10 seconds left, Mia. Were there any questions that came up? And I know many of you will have to leave, but we'll keep the recording going, and you can check back in for questions if you have them.